go live on the internet. We're going to start Chapter 5 today. Chapter 5. Chapter 5. We are going to do the best thing you could possibly do the day before Valentine's Day. We're going to take a break from our ex. We're going to talk about probability and statistics. Actually, Natasha's class, on the rare occasion, they're actually ahead of us right now, so she could teach us this if she wanted to.
Come on.
I think it's silly because it's really like easy stuff, and my whole class is like 17 steps behind some of the others. And it's dumb.
All right, interesting. So let's give you some definitions today. Today's about probability. What is probability? Yeah, we don't like to use pronouns in math. Probability is the chance that an event is to occur. Probability is the chance that an event is to occur. So let's give, and you know, first day in a new topic, it's a lot of definitions, like the very first. Bonzer! Shh!
Woo! I was trying to see if
She's
Linnea would
leaving,
send me
so
notes
she's
because I
getting
have to
my-
leave.
She's making sure this is Bill's class.
Okay, good job. A lot, like the first day of algebra, we gave a lot of definitions. Today is a lot of definitions. P parenthesis A is defined as the probability event A will occur.
I just found the illustration though.
Shh.
What?
My other class got like 20 minutes to work on homework today, and they got it almost all done. I want to give you guys that chance too.
That's probably not going to
That's
happen.
exactly what Mr. DeMeyer said yesterday.
Because we're working on probability, I'd say the chance of that happening is probably not very high for this class.
Is this English class? Like, X is equal to probably pretty low. Like, factor out that polynomial, probably pretty low. No, we're going to find exact numbers today. Probability event A is to occur. Probability event A is to occur. Okay. Oh, yeah. That's what I actually need. That's why I have the book out, so I can copy some vocab words out for you. We can talk about what it is. What do we do in probability? We run experiments. Probability experiment. What's a probability experiment? It's an action or a trial. An action or a trial that results. Oops, results. In a varying result. An action or trial that results in America. Rebecca, can you raise your hand, girl? Kara Peterson was gone today, so first period went insanely well because there's nobody talking. Are you trying to make up for her?
No.
Good.
She
Then
asked me a
I
question.
asked her what the first word said.
Oh my god.
I'm right here.
I'm getting in
I'm
trouble.
right
I
here.
literally, I
I'm
just asked
right
the universe
here.
and she answered.
Probability experiment is an action.
I don't care who answered my question.
Can we call it snow right now? An action or a trial that results in a varying result.
This is tomorrow night. I need the practice.
Good. An action or a trial that results in a varying result.
Exactly.
The results are called outcomes.
Lesbians in here that are great.
Outcomes. What are outcomes? The result. Yep. The result you see occur. Like one of the first examples I'm going to ask you to do is we're going to find the probability you get 2 questions in a row correct on the SAT. The result you would see would be like you put A and you put B. You put A and you put B. We have to be really careful in this. The outcome is what you're going to see happening. You're going to think right or wrong. Right or wrong is based off probability. The outcomes are what you physically see happening. Like somebody asks you to say these. You're like, oh, what's the probability they're going to say yes? They're going to physically say yes or no. That may result in your heart getting broken or in you like dancing like Ella over there on the sidelines before class started. But what you physically see happening is the yes or the no. The outcome is the result that you see occurring. A collection of results are called an event. They're a collection of outcomes. Brother, I can't think with you talking. Shh. Becca was bringing up Catholic school, or bringing up school.
I was?
Man, when I went to Catholic school, if you talked, they'd slap your wrist the first time and then slap your mouth the second time, but I only saw somebody get the mouth once.
They do soap?
They didn't have to. They just hit you.
No.
Just letting you know, if they hit you in the mouth, soap isn't going to hurt that much afterwards. Like, it's not that bad.
No, like if you said a bad word, if they put soap in your mouth.
No, you had to go pray.
What?
You had to go pray.
For what?
I went to a Catholic school.
Why would you pray after you say a bad word?
So the chick was because it's a sin.
You needed some time to talk to the big guy
Oh.
about what you've done and how you're never going to do it again. Yeah, you had to spend some time talking to somebody who you're really accountable to. Or at least that's what they made you do in Catholic school. Right, event is collection of outcomes. Like you ask 4 people to Sadie's. The first one says no. The second one says no. The third one says no. The fourth one says, you really got denied 3 times before me? No. That is an event. That's a collection of outcomes. You saw 4 people said no to you. The outcome is the individual event you see happening. A collection of them is called, an outcome is the individual thing you saw occurring. A collection of those is called an event. If you take the set of all possible events, that's called the sample space, but I put space first for some reason. The sample space is the set of all possible outcomes. Or if it's a collection, it would be events. Sample space is a set of all possible outcomes. So let's give a definition of probability. The probability of event A is equal to the number of outcomes for event A divided by the total number of outcomes. So for example, let's pretend we get new seats in this class and you're like, oh, I hope I get sat next to a girl. The probability of that would be the number of girls in this class divided by the total number of outcomes that could occur. Don't forget the desk could actually be empty too. We have to include that in the set of possible outcomes as well. But the probability of event A is the number of ways that event can happen divided by the total number of ways. So the number of outcomes that have event A in it divided by the total number of outcomes. Ella?
No?
Yes?
No, I just got damn, really
I can't imagine why. All that dancing earlier. Other questions? Okay, probability has 2 big questions in it. Okay, that was the end. That was the end. Probability has 2 big questions in it. Number 1, does the order matter? What? Oh boy, what is up with you guys today? First period was like saintly. Kira was gone, but saintly.
Are you sure about that?
Talking about the weather. Yeah, I'm talking about the weather.
I feel like you're making talking about
I know, squirrel, just squirrel. Okay, let's all look at the snow. Spend 10 seconds looking at the snow. Make your favorite comments to the person sitting next to you about the snow. Rebecca, it's always 69 degrees in here.
Why?
That's the temperature the district sets it at.
Wait, for real?
Yeah, in my room, yeah.
I am still concerned why the weather says there's a 0% chance of snow.
No.
Literally, like, it says cloudy. Because it's just cloudy.
All right, ready, set, back together. Here we go. Okay.
Precipitation, 0 inches.
It says there's a 20% chance of snow.
There should be a 100%
And stop.
I am not.
And stop.
That's your cutoff.
Back to math.
Back to math. Thank you. I gave you 30 seconds. It is snowing outside. The snow is white and it is wet. We've confirmed all we need to know about the universe right now. The probability of A is the number of outcomes in 8 divided by the total number of outcomes. So let's give you an example to do. Example number 1. Part A. You answer. No, you are given, because I need that word to be different than it was first period. You are given 2 SAT questions. What is the sample space? In other words, the set of all possible outcomes. What's the sample space of your responses?
How many multiple choices are there?
You have to look in your packet.
Well, it depends
4.
what question it is.
Yeah, there's 4. 2 SAT questions. What's the sample space of your responses? Then I got part B for you. What's the probability you get both right? Now, more than likely you're going to get part A wrong, which is going to lead you to part B, so let me help you real quick. If there are 4 answers, what are the potential outcomes you could physically see from 2 SAT questions? Yep. A is one of them. Yep. A, B. Okay, so for the first question, you can answer or you could leave it blank. Right. Don't forget that when you're figuring out your sample space. Or, not a smart strategy, but don't forget your SAT score is actually your percentile. Like how many people did you beat that took the test that day? You love people that leave stuff blank because you aren't going to lose to them. Write down the sample space. So Elena gave us a couple: A, B, blank B. Write down the entire sample space in the part B. What's the probability you get both right? It's probably you get both questions right. Marks get set math. Marks get set math. And you totally talk. Now you can totally talk to the person sitting next to you. Talk. Go. Oh, Dom, you know how happy I'd be if we got a snow day tomorrow?
Yeah, you know how depressed I would be? Why? Because I've already waited a year and a half to get my regionals run, and it'd be shut down.
Huh?
And that just would not make me a happy camper.
Well, there's a reason that nobody ate.
However, comma, if it does mean that season's over early,
The probability that you get one of them right is 1 out of 4.
Yeah, I think the first one is 16.
Yeah. So then, since it's 1 out of 4, then you get, 2 problems.
So there's 16
Multiply
possible
them.
outcomes. So the answer to A16. Yeah. And then the B is you have a 1 in 16 chance to die. First one is
16. Because only one of those possible outcomes is the correct answer.
yo, I low-key
Guess
just
what?
found like my love in life.
Your love life?
Coconut berry Red Bull is delicious.
That's Ava's favorite Red
Absolute
Bull.
best flavor ever.
I don't drink that many Red Bulls. I don't drink energy drinks.
I don't really, but I like just started because they're 8 ounces. They give you plenty of energy for practice right after. And
So wait, which one is this?
the caffeine to juice ratio like doesn't make me super jittery.
Well, that's
when
the
I'm
problem I
wrestling.
have with Red Bulls is I get to like, it's not like as much energy, it's more just like jittery.
I don't know. Those ones give you more energy than jitters.
So these ones?
I don't know. This like the juice to caffeine ratio just doesn't make me jittery.
All right, volunteer, sample
But like a
space.
bang?
Volunteer,
Oh, dude.
sample space. Yes, Rebecca Anderson, please.
16.
What's that?
16?
I think there's more. I think there's more.
5.
List your sample space for me, like the actual outcomes you're seeing. You could have put A, AA,
AB,
yep,
AC,
yep.
AD,
Okay, now talk faster.
BA.
You're doing. What are you forgetting though? Blank, right? Because you could have left blank.
Well, no,
Or
you told us not to
blank.
do that.
Well, I said you're given 2 questions. Part of the probability is some people are going to leave it blank. Believe it or not, one of the things the lottery has to figure out when it's figuring is a lot of people actually have a winning ticket and never turn it in. They don't.
Why?
Yeah.
Well,
Why? Too lazy, not enough work, they forget, they lose it, a lot of reasons. But
Well, some
part of
people
what you
are
have to figure out on the SAT is some people are going to run out of time and actually leave stuff blank. That's why I told you guys, make sure you bring an old school kitchen timer or like an old school watch, not like this one that sends or receives a signal. When you get down to 1 minute left, you make sure you have an answer for every question at 1 minute left. Like, you don't want to be, like, filling in blanks with 2 seconds left and then they say pencils up and you're out of luck. Like, with 1 minute left, you fill in the blanks of the ones you have not answered yet. Then, if you get 10, 20, 30 seconds left, you go try to answer another question and figure it out. But this way, for sure, you have an answer for every single one. Because when they say pencils up, they're not kidding. And if you have your pencil writing after pencils up, like, they'll disqualify your whole test. They should. But part of it is they are going to leave stuff blank. I mean, I'll be honest, in the corporate world, I worked as an actuary. We counted on 30% of our accounts paying late every single month. In other words, they gave us a $39 late fee just to pay later. So that's it's a possible outcome in the sample space. So when you include blank, how many do you get?
25.
25, right. Because there's 5 options for the first one, blank, A, B, C, D. There's 5 for the second one. When you match up all those combinations, you're going to get 25. But what is the actual sample space of the event? So you need to have like A, B, A, C, A, D, B, A, B, 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 C, D, D, C, A, C, B, C, B, C, 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 D, blank A, blank B, blank, blah, 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 blah. All 25 of those. What's the probability you get both right, though? Yep, Max.
125.
Because how many right answers are there? And how many total outcomes are there possible?
25.
Yeah, there's 25. So you got a 1 in 25 chance. You got a 1 in 25 chance. Now, do only 1 in 25 kids get it right? No, because there's 2 big questions of probability. Number 1, does the order matter? Number 2, does the probability of the first event affect the probability of the second event?
No.
And in this one, no, it doesn't. The third question that we don't get to in this class, but you get to when you take stats at some point in your high school career is, what if they are not equally weighted? In other words, what if A, the probability of A is different than the probability of B, different than the probability of C, different than the probability of D? Like, how do you take those unequal weighted answers? Like those of you who play basketball, there's a way better chance you're going to hit a layup than a three-pointer. So we can't just say, like, you're going to hit 1 in every 10 shots. It depends. Depends on what type of shot it is. Same with probability. What if there's different probabilities? Millie.
So how do you write the sample spaces?
That's my
Like,
Guitar. It's a gear.
And then just kind of separating each outcome that could occur.
And that's how you do sample space?
Yep.
It's no longer.
And then if you really want to be fancy, Millie, ready for this?
So you can't just
Show those people at other schools what's up. It's a set, so you put the bracket notation, remembering from the glory days of Algebra 1, back into that.
Fancy.
Oh, you're supposed to write all of them.
Yeah, all of them. All right, let's keep on trucking because we got a lot to cover today. Theoretical probability. The probability that should occur. The probability of an event that should occur. And again, I defined it earlier. That's the total number of outcomes for A divided by the number of outcomes that have A divided by the total number of outcomes. That's what should occur. But you know, like somebody brought up an example of first period. Like you have a deck of cards. There's 4 aces. There's 52 cards total. That's 1 in every 13 cards. If you draw a card out randomly and put it back, how often should you get an ace?
1 out of every 30.
But you know, sometimes they draw an ace on the first one and the second one, and then you're like, okay, there's something wrong here. Like, that shouldn't happen. Theoretical probability is what should occur. There's a second one called observed or experimental probability. Thank you. Done. Observed or experimental probability, which is the number is equal to the number of successes divided by the number of total trials. But that's what you actually see happen, and that can vary wildly with what's expected or theoretical probability. Like you hear people that go to the casino and they like win their first 10 hands at a given game. The theoretical probability of that's really low, but if that's what you observe happening, that's what's actually occurred. Theoretical is what should happen, and the good news of the casino is they have thousands of people playing at any given time. They don't really worry about observed probability unless somebody's cheating. They get the benefit of theoretical probability because the number of trials are large. Weird things can happen in a small number of occurrences. Like you go around, you ask 10 people to Sadie's, they all say yes. think you're Don Juan of the school. But then they all find out about it, and suddenly you're going by yourself. In small batches, weird things can be observed. Theoretical is what should occur. In the long term, observed is more like short-term probability, like what you actually saw happen. So theoretical, the probability that should occur. Observed or experimental probability, the number of successes divided by the total number of trials. Trey,
That was my question.
that's what I thought. Other questions? Other questions? Let's talk about complementary events. Complementary events are defined by the probability of event A is equal to 1 minus the probability of not event A. The probability of event A is equal to 1 minus the probability of not event A. These are either or situations. Then Dom, remind me after this, I got to talk about domain. I should have talked about it earlier, but I missed it. Either or situations.
Just after we cover this vocabulary or after
Yeah.
this point?
After this
Oh.
point. Well, both. Somebody give me an example of an either or situation, like the probability you do it or the probability you don't do it.
Clean your room.
Clean your room. If the probability you clean your room is 30%, what's the probability you don't clean your room? 70%. So notice they sum to 1.00. What's another example? Another example.
When you flip a coin, you get
Good job. Right. The probability that your Valentine comes through for you and gets you that graphing calculator you've always dreamed of is equal to 1 minus the probability that they don't. But that varies wildly relationship to relationship. However, good news. This classroom has all the answers you've ever needed. Let's pretend like just in a brand new relationship. You're not like dropping $100 not happening because you're not sure if this is going to survive the weekend. Good news. There's candy up there you can buy for $1. Sweets for your sweet thing. You buy that. You checked off the box for Valentine's Day. Good enough. Maybe not the best gift you're ever going to give, but you just started dating this afternoon. Or even worse, somebody asks you out on Valentine's Day, and you're like, can we do this on the 16th? Yeah, that's kind of inexpensive. But maybe you're in just a little bit more committed relationship for this, and you're saying, man, look at that Christian. Look at Zach. Look at Mr. Beckman. They are looking good. Wish I had one of them shirts. Good news. We are selling these sweet shirts for $10 each. We got just a few left in every size. But if you're in that kind of commitment, like a little bit more than $1, but not quite graphing calculator yet, you can totally buy one of these. They are so comfortable. They are so nice. They're that same shirt that you got at the start of the year, just with a sweet DCC logo on it. They got great sponsors on the back. Some of you even work for them. Yeah, you can do that. Or, just so you know, Walmart's going to be open late tonight. You need to get that graphing calculator. They got the TI Inspire CX-CAS in stock right now. And if you order by 4 p.m. tonight, Amazon can get it here tomorrow if they haven't sold out yet. Christian.
If they haven't
I don't
sold out
understand
yet.
like what the one is. Like why is there a one?
Well, let's go what I was saying I should have covered earlier. Let me ask you a question, Christian. If the probability of an event A has to be between two numbers all the time. Natasha, can you pull that screen down? I'm sorry, you guys, I didn't realize that was up. Can you pull that screen down, put it underneath the books, please? What two numbers does the probability of every single event have to lie between? 1 and 0, right? 100% and 0%. Somebody tells you to give 100%, you just say, I don't think you understand probability very well. Because the number of outcomes that are successful cannot be more than the total number of outcomes in the sample space. And that's going to ruin their mojo. Like coach goes up and says, give 110%. You'd be like, I think you need to talk to your wife about math real quick. Just be like, the total number of successful outcomes of this match can't be more than the total number of outcomes of the match, period.
What about
Yep.
finance?
What's that? If somebody's charging you 110%, they are ripping you off. If they're giving you 110%, you sign up and just say, how much money can I invest?
Business has grown 110% over the last
But that's not a probability. That's a percentage of growth. I do that all the time. I usually do it during first period, though, so you guys don't see it. The probability, now the growth potential, yeah. If you made $5 this year and you make $50,000 next year, your growth is more than that. But a probability is defined as number of successful outcomes divided by total number of outcomes. If somehow you have more ways to be successful than you have total number of ways, you're in trouble. You're in trouble. And that's where you go back to those rigorous definitions.
You're either in trouble or an extremely successful.
That's
man.
what I was gonna say. I was like, that doesn't sound like you'd be in too much trouble.
People, I cannot have you going out into the world and being like, there's about a 130% chance we're going to win this game today. Or even worse, going on Facebook and ruin it for all of us and be like, there's a 114% chance we're going to have a snow day tomorrow.
Why would you do that?
No, there can't be more snow days than
There's a
tomorrow.
110% chance that no matter what happens this Saturday, I'm gonna lay my hands in a very aggressive way on a kid. That I just want to beat.
So there's no way ever in the history of ever that there could be more than 100%.
That the probability of an event could be more than 100%? Absolutely not. The number of successful outcomes cannot be more than the total number of outcomes. They could be equal. They could be equal. Other questions? Like so far, the probability of the sun rising in the morning is 100% of the days I've been alive.
Well, unless you're like down in like this, like if you're like in the winter and like one of the cold.
Yeah, I'm a teacher. I can't afford to go to those places. That's above my income bracket. Other questions? What's that? Well, if you're born there, then your probability would be different than mine. Other questions? All right, so Christian asked a question about, I don't understand. Well, really what we're saying is the probability of A. Another way of saying that is the probability of A plus the probability of not A is equal to 1 if A and not A are complementary.
But if they're not,
America, we raise our hands. Yep.
so if they're not, and say like the probability of me buying a donut and the probability of me
Not buying a donut.
talking to Linnea today are completely not
Right,
complementary.
they're not complementary.
They
The probabilities are not going to add up to 100%. So let's go back to the room example. If the probability you're going to clean your room is 31%, what's the probability you don't clean your room? 69%, right. 69%. Oh, I'm sorry. Am I teaching at the middle school today? Like,
Yeah.
really?
Middle schoolers in here.
Really? Got that. Okay, let's get some data from this class real quick. I've got 8th graders. I got freshmen, sophomores, juniors, and seniors.
There's seniors in here?
No.
I was about to be like, oh.
The talking. It's just an infection today. Why can't y'all be look at poor Practo back there, just like meditating in his own genius back there silently. 8th graders, how many? Raise your hand if you're an 8th grader. There's 3. Raise your hand if you're a freshman. 2, 4, 6, 8, 10, 11. Sophomores. 2, 4, 6, 8, 10, 12. Juniors. Are you a junior?
No.
You're a
What?
sophomore. Juniors, seniors. Nice try. 0. Here's what I want you to do. Find the probability that if you pick a random person to be your partner, they are a freshman. The probability that they're a junior. And the probability that they're a senior. On your marks, get set, go. On your marks, get set, go. Yep. On your marks, get set, go.
I don't know.
No, but Rainford's got a lot.
What about probability they're an 8th grader?
Didn't ask that one.
Why not?
Do you have an extra for this? So, yeah. Was that sitting in the drawers? Yeah. Yep.
I didn't know if it was your favorite. You were saying that. What you guys working on?
Probability. First day intro. Struggling with complementary a little bit. Mr. Breebach, can you give us an example of 2 events that are complementary? And then tell us how they meet the definition of complementary events.
What's the definition of complementary?
relating.
P of A equals 1 minus P of A.
Okay.
No, you're close. Think about that again. You were close.
Oh, P of not A.
Say the whole-
minus
say the
P
sentence
of A equals 1 minus P of not A.
Okay. So what's
So in other words, P of A plus P of not A equals 1, right?
Uh-huh.
So we need 2 events whose probability ends up in 1.
Mm-hmm.
So it will snow tonight. It will not snow tonight.
Just choose one event and then do like opposite of it.
Okay.
Not in front of it.
So we
It has to be a yes or no statement.
Okay, well, let me ask you a question. Let's go to football as an example.
Wait, hold on.
Oh,
Does it have to be a yes or no statement? So if I had a deck of cards, I could say, you will draw a red card. You will draw a black card.
But I could answer those in both a yes or no situation. If you say you will draw a black card, I will say no, I won't. I draw a red card. No, I don't. I can say yes, I do.
So you make that yes or no.
Draw a
Your
black card.
English teacher loves that too.
But I like the way you're thinking on that.
Miss Carpenter's taught me that.
Anybody else? Complimentary events? All right, finish those three real quick. Finish those three. Somebody asked first period. What if I get something like 9/27ths? Do I have to simplify that? Yeah, we were giving a placement test to the 8th graders yesterday. Somebody asked that question. I just said yes for the rest of your life. You can
And again,
simplify
yeah,
it.
why wouldn't you?
I don't know. I don't know when that went away, but for the rest of your life, you get 9/27ths. You better simplify
You
it.
may as well. Unless you're fixing to add it to 10/27.
True that. True that. Natasha, there's a box of t-shirts back there. Can you help me just sort them by size? There's a couple of groups that have merged into one.
Thanks for letting me hang out with your smart kids.
growing tired.
You're lucky. You walked in at the right time. They were on fire with talking the entire period until about a second before you walked in. So
Like off-topic stuff?
just everything. Everything.
The snow.
Like the snow.
Oh, so
just-
then
they-
I
like
come in and it'll snow, it won't snow, it didn't help any.
well,
So,
it destroyed the distraction value of snow. So. All right, victims. Ella, you already talked today. Grant, probability of freshman is what? I love how much this is stressing her out, and I'm not even calling on her. Grant, probability of freshman is what?
I said 11 out of 28.
Where'd you get 28 from?
Because you can also sit next to no.
Okay, good. That's true. I didn't even think about that. That's a good one. That's a good one. Because it is possible that if I sit you next to somebody, you could sit next to no one. And remember, the question was, if you picked a random person to sit next to you, what's the probability that it's a freshman, junior, senior? Yeah, that's Grant. I didn't even think of that one. That's a good one.
However, if you...
Guys, stop. There's way too much. Guys, shh. Part of what's making things confusing today is there's all this random talking. Structure and order keep things going. If you got something to say, raise your hand. If I want you to talk, I'll let you know. Part B, juniors. I need a victim for juniors. Parnika, what'd you get for juniors? 1 out of 28. Okay. Somebody else. Dylan, seniors.
0.
Why are there 0?
Because there's no seniors in our class.
But use probability vocab. There is no...
No possible outcomes for,
Keep going. You're awesome so far. Where there's no possible outcome where a...
where a senior would be sitting
Right, where a senior would be sitting
next.
next to you. Right on the money. Christian, yes, sir.
So like, I'm like kind of confused because like, couldn't we just like add a bunch of like different probabilities? So like, Grant said like you might not sit next one. Then can you say, oh, there's a probability that you'll sit next to your mom, so you have to like add another. Where do we, like,
Okay,
draw
let's.
the line?
If we're gonna go crazy, let's go. Let's just have Thomas come in class and sit next to you and just be like, "Shut up now! You're embarrassing our family name. Don't ever talk again, dude." Thomas, obviously you two know your older brother, but Thomas told people what he thought. One day in count class, I thought Jay Costco was gonna punch him, but then I think he realized Tommy would kill him. So that was a good choice. Other questions, Alex?
So it does have to be over 27.
I would take it if it was 27 or 28 because I didn't actually write the question down that I told you to answer.
You had to pick someone to sit next to.
If you had to pick, yeah, and that's why I would count either one. Hold the. Yeah, I should have wrote the question down, and that's. I would let you take advantage of my ambiguity on that one. So yes. Other questions? All right, now I got a good one for you. How many think you got this down? Okay, I got a good question for you. This is an honors level question. All right, so you have waited until the last minute to ask somebody to say these, but you're going to tomorrow night, the night before the dance. But you're only going to give them a chance. So you set up the obligatory poster board that you have to use to ask somebody to say these. But this is a big one. It's 4 feet by 4 feet. Hey, if you're going to wait, we're going to wait, you got to go big. And you give them a dart, and you're like, okay, if you hit the circle with the dart, we're going to Sadie's together. If you don't, we're not going together. Yeah, you see. If they hit, no. If they miss, you're not going to embarrass them. You're going to give them another shot to hit the board. You're not that mean.
What if they intentionally miss?
Yeah.
They don't want to go with you. They don't want to go with you.
Yeah, how does that
Now, here's bad news. The radius of this is 2. To what inches? Because you're also saying, can they do some math before I spend 7 hours on a date with them? Here's the question: if you throw a dart at this board, what is the probability it lands in the circle? Of negligible size, tiny. All right, now here's the weird part. Out of all this probability stuff, this is the question they like to put on there because then they can check off the box for both geometry and probability. So they can check a box off for that. Round it to the nearest hundredths. What's the probability? If you throw a dart at this board, that it lands in there, and then that's the probability that you got a date for Sadie's. If not, hashtag solo.
Okay, so it's
All right, work the person next to you. Ready, set, go. Yes. Yes.
What'd you say to round 2?
What?
What'd you say to round 2?
Yeah, is it?
I don't know.
Mr. Beckman, what did you say to round?
Hundreds.
Yeah, where's that time?
Oh. It's right here. On the carrot. It's blue carrot.
Mr. Beckman, can I come in tomorrow to finish my test?
When?
During B lunch?
Yeah.
Where?
The carrot.
Oh.
What?
Excuse me.
So, wait.
Said round what?
And we have it down at foot in diameter. If you want to know it's about a 16. It's
4
about.
feet.
Is the radius or the area of the circle?
No, it's nearest.
No, it's
It's about a 6 point. It's about a 6%.
So it's 12.7.
That if you throw a dart
But
at a
like,
ball,
are we going to
No, we
account
said
for
about
that?
a 6% chance.
The probability exists that you might not hit the board?
But 16 times 12.
Wait, probability that you just hit the circle is like infinity. Because like technically, it's just like you could hit outside of the board anywhere.
Is it fine to the board?
Oh, wait, I need to skip the class.
No, but like for real,
I feel like, okay, but I feel like in this scenario though, if they miss the board, I feel like you would just eliminate them from
but that's still an
Hold
option.
on.
Is like,
Yeah, no.
you know,
Let's throw it up. Wait.
48 by 48. But hold on. I think I did something.
what if they like go for it while they're like
Right. There's
pulling back, and they just throw it behind them? Hit their friend in the eye. Mr. Beckman, is this the probability that you just hit the circle?
What if you don't hit the board?
If it's outside the board, you let that free.
So that's not.
So we're not counting that.
Divided by 50.
That's what we were writing. I had to vote it. Like, why is it? No, maybe that was.
Yeah, that's what I'm saying. Or it was 0.005. But you did say go to the 100th place? Yeah.
No.
Except remember, you said go to the 100th place. That's what I remember.
Mint? You want mint? Talk to me. I got tons of them. It's not with me. I got that.
So I think I got it.
My legs hurt.
I got some mad geometric skills, brother.
Shut up.
I really hope this is right.
All right, volunteer to come and show us how this works. Talk today. Talk today. Have you talked today?
I've talked a lot today.
Come on, Christian Clayhands. Come on down.
Do your legs not hurt after you sit for like an hour?
Like, didn't really write much stuff down.
Take us through your work. You can show your calculator. We'd love that.
I already deleted everything.
Go back.
Biscuits might have showed. Can I show you how to bring it back up? Ready for this? Second, enter. Second, enter. Second. Oh, he totally deleted it.
Oh my god.
Some
Why
people's
would I
children.
not? You have to
No
clear
wonder
your
Tommy's
history.
No wonder Tommy's yelling.
That
At
look
you.
about the same.
All right, go.
Wait. Okay.
Yeah.
Okay, so I'll just like write it so it's easier.
First, make them be quiet.
Be quiet, thank you. So I did. Oh wait, no, that's not how I did it. Okay, basically I just did 2 pi r, cause that's the how to get the area. No, oh yeah, pi r squared, cause that's how you get the circumference or the area. Sorry.
Yeah.
It's like really delayed. That's throwing me off.
Yeah, I
Okay.
know it's weird because it's like you're 10 seconds behind.
Yeah, okay. So then you get 12.57, so that would be the area in the circle. And the total area of the rectangle is 16 feet. But since the area of the circle is in inches, you have to convert it to inches. So it would be 12.57 over 192.
Which is about what percentage? Get a calculator sitting right there, brother. Use it. Your parents or whoever bought that for you, they didn't give it to you for the sit.
Points or 6%, 6.54%.
And remember earlier in the class period, I told you how you'd get to give somebody about a 6.5% chance of going to homecoming with you, or sorry, Sadie's with you.
Oh, you did say that.
Yeah.
Wow.
See the future.
Wow.
All right. Questions?
It's like this.
Yeah?
Yeah.
Oh, okay.
No, but
Yeah,
do that.
I am kind of confuzzled because my number
I
ended
know.
up
I can't. What is going on? Shh.
slightly different because I converted the 4 feet and 4 feet into 48 inches respectively, and then multiplied those two together and got 2,304.
Okay.
Well.
And that resulted me in a like 1% chance. Because the decimal you get
Well, work
is
through it. Work through it. Talk to each other.
They
Yep.
only converted one of the feet to inches. So when you multiply 48 times 4, it gives you 192, which is.
What?
No, because I converted it
Process.
after.
No. Well, he's talking about John. Your answer's totally correct. You're fine. Keep going.
I'm really okay.
No, I was just
You're
no,
good.
it wasn't correct.
Okay, keep going.
Because he multiplied, so I'm assuming he multiplied 16, or he multiplied 4 by 4 to get 16. And then he converted that to inches by 12, by multiplying by 12.
Talk to him. Tell
Yeah.
him what you did one more time. Because That was not what I heard you did.
Okay, so well, that is kind of what I did. So first I found the area of the circle in inches, but then I converted it afterwards. So yeah, I multiplied. Did I? Yeah, I multiplied 4 by 4, and then I converted it.
Okay, and then what Dom did was he multiplied 4 by 12 to get the inches for both sides.
Yeah.
And then he multiplied 48 by 48 to get 2,304.
Okay, so he converted it to inches, and I still got 6%. Right there in my calculator.
I got 1%.
Yeah, because the decimal, when you divide, so the 12.57 I totally agree on, but 12.57 divided by 2,304 resulted in 0.005 blah 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 blah, which would get rounded up to 0.01 if you're going to the hundredths place.
Okay.
But
So that would give us the 1%.
Talk through this. There's a right answer in here somewhere. Let's talk through this. You run the conversation. You're in charge, brother.
Does anyone know? I don't know.
Burr, go ahead.
well, when
I
I
don't think we have consensus on what is the right answer yet.
I multiplied 4, just see what happened.
Good
I
luck.
multiplied 4 by 12 to get 48, and then multiplied 48 by 48 and got 2,304, and then divided that by 12, and it gave me 192.
Okay, so here you guys wanting to do it a different way. But let's think what Christian did and talk about what he needed to do.
Did
Okay,
I do it wrong?
I will agree there is a conversion error in here, but the conversion error we got to be able to figure out. So you guys are saying do it a different way, convert everything to inches. He wanted to stick with feet, and he divided it by 12 to convert it to feet. Talk to me about that real quick, Christian. Run the conversation.
What am I supposed to say?
Call somebody. Look at all these people eager to help
Max.
you.
Is it because it goes to feet squared, so then you have to square the inches?
Okay, so what's he need to do?
Okay, did I do this wrong, or did someone else do this wrong?
We are
That's
yet
all
to
I
agree
want.
on that.
But then why are you saying he needs to do this? That's freaking me out, because what if I did this wrong?
You might have forgot a number, but that's okay. Brother. Don't judge each other on now. That's why we do informational quizzes. We want you to be perfect at the end, not to start. Alex?
Alright, so the reason you have to convert it into inches or is because 1 square foot
Yep.
is 12 inches by 12 inches.
Yep.
And so if you just say it's 1 square foot and multiply by 12,
Okay.
then that's only 12 inches, but it should be 144 square inches.
Okay.
And so you have to, it's feet squared. So
Okay.
you also have to square the inches instead of just multiplying by 12.
Okay. So he divided by 12. So what he did is he found the area first. So he took pi r squared, so 2 times pi squared, and then divided it by 12. Was that? Oh, sorry, multiplied. Yes, multiplied by 12 because there's 12 feet in there's 12 inches in a foot. What should he have done?
Multiplied by 144.
Right, because 144 is how many. So if you're going to convert inches squared to feet squared, there's 100. Guys, stop talking. Think of 1 by 1 square. 1 foot by 1 foot. How many inches is this side? 12. How many inches is this side?
12.
So in inches squared, how many inches squared do you have? So as soon as he found the area, he doesn't have inches anymore. He has inches squared. So he can't divide by 12. He can't multiply by 12. He's got to multiply by 44. Now take 10 seconds on your own to figure that out. 10 seconds on your own to figure that out. What would that answer be if he multiplied by 144? 144.
I'm confused because I don't know what.
Take questions. I'm not going to take a question right now.
So you lied to us before grabbing class because it's not 6%.
I feel like I set you up.
You did set us up.
Yeah.
You did that
Yeah, I totally did that on purpose.
I don't.
He's covering it up.
Can I show a little bit of work here? So here's what he did. He said, okay, pi times the radius squared divided by 4 times 4. So we got is 12.57 inches squared over 16 feet squared. And then he multiplied this by 12 to get 1257 inches squared. divided by, what is that, 192? Yeah, 192 inches squared. Where's the error? Yep, Linnea?
It's 16 feet squared, and so it needs to be multiplied by 12 inches squared.
Right, 12 inches squared, but there's not 12 inches squared in a foot squared. There's how many? 144, right. So you should have multiplied by 144. When you multiply by 144, that would have given him 2304. So 12.57 inches squared divided by 2304 inches squared, which is about 0.5%.
This is really complicated.
Now, here's the weird part. On the SAT, ACT, they don't do a whole lot with probability, but they like to put probability in with something else. So they put it in with geometry, and then they put you with some weird units. In that case, those who took chemistry, like you've had this drilled in your head all year, you don't need any practice on this because you've already gotten so much. Those of you who haven't taken chemistry, they're going to teach you railroad tracks next year. They'll teach you how to convert units by following the railroad tracks.
No, he never did. He kind of just expected us to know it.
Dude.
What is railroad?
No.
That's fine.
He really did just expect us to know it and convert on our
Okay,
own.
well, he expects you to just know it off the top of your head. So just know it off the top of your head then. That's another teaching strategy. Just know. Yeah.
Just know.
So
know.
is it okay if, like, instead of doing that times the little button that's pi, we just did 3.14?
I guess if you like imprecise answers. I mean, that's probably what Iran did when they were trying to take out that American facility. They just multiplied by 3.14. No, 3.14159. You want to have all the decimals you can. You want to be as accurate as possible. Millie.
Okay, so I'm just kind of confused. I did what Dom did, where I found 4 feet and multiplied like 48 by 48.
Yeah, and that's totally correct, totally fine. I was trying to.
How to do the circle different because I
Then don't.
But then
You don't have to find two ways to do this correct. You only have to find one. If you convert everything to inches right away, that's absolutely fine. Then everything's in inches, you're good to go.
but it isn't the same.
You didn't get half of 0.005?
Wait, but like, are you saying that you know how to find the circle? No.
So let me show the other way to do this that I was trying to force you away from. But 4 feet is how many inches? 48. 4 feet's how many inches? 48. And for, I guess since you haven't learned railroad tracks, when you look at a problem that has different units in it, convert it right away. Don't wait until the end to convert it because then you forget something like feet squared. If you then work it, okay, then you say, okay, the area of the circle is pi times r squared. That's your numerator. That's your successful area. Divided by your denominator, which is your total area, 48 times 48. That's totally fine. That'll get you the correct answer. That's what you're going to end up with down here as well. Just converting at the end instead of the start. And I highly suggest you always convert at the start if you can. If you throw that in your calculator, then you're still going to get 0.005. So Millie, I would do that. I would convert units right away so everything's in the same unit right away, and then you just roll with the problem. If you do that, then you're going to get this as your setup, and that is your answer.
Is that how?
Yeah.
Go ahead.
I don't get how you got the 6.54 then, because that's not the
It's wrong.
Oh, okay. I was like,
You don't want the 6.54. You want 0.005. 0.005 is your correct answer.
Alright, that clears it up.
Yes, which is why I highly suggest you convert immediately at the start. Don't wait till the end. Dom, then let's get you to your homework so you got some time to work.
Why don't you round up because you requested the hundredths place?
Ooh, hold on just a sec. Yeah, I would round up the point to 1%.
And this person must not really wanted to go with the person that they
I
asked.
know.
Like,
That's pretty tough.
0.1%.
like
You're a first-round draft pick. If they haven't got skills, what are you going to do for 7 hours together?
7 hours.
I mean,
7 hours.
by the time you go to dinner, go to the dance, drop them off, how long a day are we talking about? I know we're talking more like 9 hours, and then you add pictures on top of that. What girl has ever taken pictures in less than 2 hours for a dance ever in their life?
Me.
Yeah, that's what they all say. Christian, give him give him 1 on 3. 1, 2. You take your notebook back with you too. All right, let me give you some work done. I'll take some questions. Here's your assignment for tonight. Weird, it's out of the book. It's out of the book. I know. Where is yours? Luckily, there's a stack of them behind Dylan right now. That's your assignment for tonight. The last one we did is the hardest one, like the honors level problem. Most of them, you just have to figure out the number of marbles you have. Yeah, Kessler. Yes. Yep. Well, it's the thing. 4 feet is about this. So this by.
May I get to the restroom?
Yes. So you got 4 feet by 4 feet. That's your circle you have to hit. That's about
What is
1/100 of the
MP?
area.
Because realistically, the bullseye would have been like
right
that.
here,
big.
that's about 4 feet by 4 feet.
Not
2
that
inches
big.
is
Maybe
not that
probably.
wide. So you
Like,
have a circle that's about that
Or
wide.
100th of a poster.
That's a big ass poster.
Mr.
Yeah, no,
Beckman.
it's
It's a tiny circle.
Yeah, no.
Well, yeah, you get one try. How many tries you gonna let
If
people
its
have?
radius is 2 inches, it'd be like this big.
Well, okay, guess let me give you. All right, hold on. Let me give you.
What is MP?
Hush! What part of hold on means start? Keep talking. Boy. Whew. Let's do it with another shape. Okay, let's do it with the triangle. That is, let's make this easy. 1 foot by 1 foot by 3 feet. And inside of that, you put a square that is 6 inches by 6 inches. Is it probable you're going to hit inside there? No, but what do you have to do? You have to find the area of the success divided by the area of the entire, and that's going to give you your probability. And that seems pretty logical to me. That could be about 1 in 100. It's a big board in a small circle. Okay, that's your assignment up there. I'll text it out to you in just a second. Shreya.
What is MP?
It's called mathematical proficiency. It's like some review problems at the end. So they're not on the current learning target, they're just review things.
They're called maybe problems.
Well, like, they're all maybe problems, I guess. Can you get another thing candy from my boy Rainford from me? Right, you guys. Sure.
Get the good stuff.
I'm bummed.
It's weird. It was snowing like crazy like 30 seconds ago. Now the sun's out.
It was the same thing that happened yesterday.
I love Colorado.
Section 10.2 in your book. No, 10.1 in your book, but it's learning target 5.1.
I think it's because Mr. Breebach changed it.
Truth.
Oh no, Tesla. Elena, look. What? You have the same size packet I have. You have.
Can we share your phone?
Oh yeah, no, that's stacked.
Kira's gonna log on to the live. Told her it's a little late, but